Hi students, hello everyone. Welcome you to the Maths online class of Anand Medical Academy. This is Kiran Potina, lecturer in Department of Mathematics in Anand Medical Academy. As your schedule is very short and tiny, let me introduce a topic of class 11 mathematics, that is linear inequalities. From the topic of linear inequalities you will get two classes and again you will get two assignments based on that classes. From the classes and assignment, you will have a small MCQ test according to the schedule. So let us start the topic of linear inequalities. Linear inequalities. So before going into linear inequalities, let us start. What do you mean by an equation? What do you mean by an equation? Equation in simple words. In simple words is nothing but in between two algebraic expressions. In between two algebraic expressions or in between two variables. If equal sign is there, like a equal to 4, x square equal to 4, right? In between two algebraic expressions or in between two variables, if equal sign is there, then that will consider as an equation, right? If equal sign is there, that will consider as an equation. Now, what do you mean by inequation? What do you mean by inequation? Inequation in the sense it is not equal. Inequation in the sense it is not equal. Now, for those inequations, what are the signs we will put? For equation we will put equal sign. For inequation, which signs will be there? Those signs will be less than, greater than, less than or equal to, greater than or equal to, and also not equal. Not equal in the sense unequal. So these are the signs we will be used in inequation. Nothing but inequality. Now here in the name, what do you mean by linear inequality? What do you mean by linear inequality? Linear in the sense, for example, when it comes to linear equation, x plus y is equal to 4. This is what linear equation. Why we will call this as linear? Linear means highest power. If it is 1 means we will consider as a linear equation. Now, before introducing linear inequalities, let us discuss what are the types of inequalities will be there. What are the types of inequalities will be there? Those are, listen all of you. In that, first one is strict inequality, that is strict inequality. Next one is slack inequality, slack inequality. Next one, double inequalities, double inequalities. Next one is linear inequality. Next one is linear inequality in one variable, in one variable, right? Next one, linear inequality, linear inequality in two variables, in two variables. Next one is a quadratic inequality, quadratic inequality in one variable, in one variable. Next one, quadratic as a linear inequality in one variable and also in two variables. Quadratic inequalities also will be in one variable and also in two variables. Quadratic inequality in two variables. Two variables. Next one, numerical inequalities. Numerical inequalities. See, if you observe these names, then you will get easily idea you will get. So what are those types also? See now, strict inequality. First one is strict inequality. You know what you mean by strict? Strict means it should be either less or greater than. It should be either less than or greater than symbol in the inequation. Then we will consider that inequality as strict inequality. It will be like 2 less than 10. X is greater than 10, right? X is less than 5. So, if the inequality contains either less than or greater than, we will consider as strict inequality. If the inequality contains x less than or equal to 2 or y greater than or equal to 5 or x is less than or equal to y. So like that, if the inequality contains either less than or equal to or greater than or equal to symbol, that inequality will consider as slack. Strict means either less than or greater than, slack means either less than or equal to or greater than or equal to. When it comes to double inequalities, in the name itself it is the double inequalities in the sense, for example, x is greater than or equal to 2, less than or equal to 5. In the inequality, if you have two unequal signs, that may be greater than or equal to, less than or equal to, that may be less than, greater than. But if you have two unequal signs, then we consider as double inequalities. Next one is linear inequality in one variable. Linear in the sense, highest power should be 1. So those type of inequalities will be like x plus 5 is less than 10 or x is greater than or equal to 20. See like this. Linear inequality one variable. This is linear when because highest power is equal to 1. So it is linear in one variable. One variable means either in terms of x or in terms of a or in terms of y, like that. Next one. Linear inequality two variables. Linear means highest power should be 1 and two variables. So it is like x plus y greater than or equal to 12, less than 10, like that. Linear and also in two variables. Next, quadratic inequality. Quadratic in the sense highest power should be 2. So quadratic inequality in one variable. In one variable is like 2x square plus 5x plus 10 is less than 0. Less than 0, like it is a quadratic inequality. Why? Because highest power is 2 in one variable, only in terms of x. Now when it comes to quadratic inequality in two variables, that is like x square plus 2y is greater than or equal to 5, like that. Here this is quadratic. Why? Because highest power is 2 and also two variables. So quadratic inequality in two variables. When it comes to linear inequalities in one variable and two variable, those signs may be less than, greater than, less than or equal to, greater than or equal to. But based on that highest power and based on number of variables, we will consider those types, these four types. Now last one, numerical inequalities. Numerical inequalities. In the name itself it is the numerical. Numerical means in between two numbers, like 2 is less than 5, right? 5 is greater than 3. So if an equal sign in between two numbers, those are nothing but numerical inequalities. See, these are the types of inequalities, right? These are the types of inequalities. Pause the video and note down. Students, now I will introduce the concept of number line and solution set. Number line and solution set in terms of intervals. How we will write the solution on number line is, for example, if x is less than 2, if the unequal sign is x is less than 2. See, whenever we consider x is less than 2, whenever we do the topic of linear inequalities, always you should remember that x is belongs to R. X is belongs to R. You know R, what is capital R? Capital R represents real numbers. Whenever we solve the problems of linear inequalities, you should remember those x value should be belongs to real numbers. Now here x is less than 2. If x is less than 2, what are the numbers? What are the numbers? If x is less than 2, what are those? 1, 0, -1, -2, like that. So those are real numbers. Can we write like this? No, we should not write like this. Why? Because if you write 1, 0, -1, -2 like that, in between 1 and 0, so many infinite numbers will be there, right or not? In between 1 and 0, 0.1 will be there, 0.2 will be there. See, so many number of numbers will be there in between 0 and 1. So you should not write the solution set like x less than 2 means 1, 0, -1. We should not write like that. Now, how we have to represent that solution in terms of number line and also in terms of intervals? When it comes to number line, draw a straight line. See, on the left hand you need to mention -infinity to infinity. Nothing but this number line represents real numbers. Number line represents real numbers, where real numbers are from -infinity to infinity, right? Now x is less than 2. So I will consider numbers like 0, this is -1, this is 1 and this is 2. Here what is the solution? X is less than 2. Is x equal to 2 here? Is x equal to 2? No. If x equal to 2, we will do dark circle for 2. Here x is not equal, nothing but x is less than 2. Now what we will do? Above the 2 we need to draw open circle. Here open circle indicates x is not equal to 2. X is not equal to 2. That means it is greater than 2 or less than 2? It is less than 2. Less than 2 means what we need to do? We need to draw a straight line like this, and we need to draw it like this. Then this represents x is less than 2 but not 2 and not greater than 2. So this is the solution set how we are representing number line. See, let us consider another example. X is greater than 7 by 2. X is greater than 7 by 2. See, further I will draw a straight line which having minus infinity to infinity numbers. In between 0 will be there. See, this is 7 by 2. 7 by 2 is nothing but 3.5, right? This is 1, this is 2, and this is 3, and this is 4, and this is so on like this. This is so on. Now 7 by 2 is nothing but in between 3 and 4 it will be there. So this is what? 7 by 2. Now x is less than or equal? No, it is greater than. That means it is not equal. Not equal means what we need to do? Above the 7.2 we need to draw open circle, right? Above the 7.2 we need to draw open circle. Then it is greater than or less than? Greater than. Greater than means this side we need to draw arrow and we need to shade this region. Then this number line represents x is greater than 7 by 2. Like that we represent the solutions in terms of number line. Now when it is strict inequality, you need to draw open circles. When it is slack inequality, like x is less than or equal to 5, if x is less than or equal to 5, if it is slack inequality, how to write? If it is 0, 1, 2, 3, 4, 5, and this is infinity to minus infinity. Now if it is slack inequality, nothing but equal sign. Equal sign means x is equal to 5 is also. That means here two signs are there. One is less than and also equal in such cases. Now here equal sign is there now. Then above the 5 what we need to do? We need to do dark circle. For strict inequality we need to do open circle. For slack we need to do dark circle. And then x is what is another sign? Another sign is less than. Less than means left side we need to draw. This side we need to draw arrow and we need to shade this region. So this represents x is less than or equal to 5. Students, note down these examples. Next one is curly brackets. Next one is curly brackets. Nothing but flower brackets. When we will use flower brackets, see, for example, if x is belongs to n, nothing but x belongs to natural numbers. Here the inequation is x is less than or equal to 6. X is less than or equal to 6. Can you write x is less than or equal to 6 in terms of number line? No, we should not write in terms of number line. When we need to represent the inequation in terms of number line, means when x is belongs to real numbers. When x is belongs to real numbers, then only we will represent in terms of number line, as we discussed previously. Now, if it is in terms of natural numbers or in terms of integers, right? Then how we need to write those x values? See, easily we can tell if x is less than or equal to 6. What are the natural numbers? So actually natural numbers in the sense 1, 2, 3, 4, 5, so on up to infinity, right? Now when x is less than or equal to 6, what are those numbers? Less than or equal to 6 means 6, 5, 4, 3, 2 and 1. So these are the numbers which are x is less than or equal to 6. Now when x is belongs to n, the numbers what we will get from the given inequation, we need to put in terms of flower brackets. In terms of flower brackets. Now when we will use flower brackets means when x is belongs to n, when x is belongs to whole numbers, when x is belongs to integers, we will use flower brackets. But when x is belongs to real numbers, then what we will use to represent the solution set? We will represent the solution set in terms of number line. See, is there, sir, you can ask, sir, is there any another method instead of number line? Yes, like this, flower brackets. Is there any brackets to represent the solution set when x belongs to r? Yes, that is there. That is interval. That is, we call it as intervals form. As these brackets, we call it as flower brackets or curly brackets. Again, when we will represent x when x belongs to r in terms of intervals. So those intervals we will discuss now. Next one is intervals. See, here we have 4 types of intervals. Those are, see, so there will be 4 types. See, this first one, these close brackets, we call this as close brackets. or nothing but square brackets, right? So these will call it as closed brackets. These will call it as open brackets. You call it as open brackets. See, these two will call it as semi-open, and semi-closed brackets. Semi-open and semi-closed brackets. Or this one we can consider as left close, right open. This one we call it as left open, right close brackets. So these are the four types of brackets which will comes under intervals. When we use these four intervals means when axis belongs to the solution of this. What is that? The solution of this will represent in terms of intervals. Now, when we use this one, and this one in terms of intervals? See, for example, if the question is x is less than 2, x is less than 2. See, how we will represent x is less than 2 in terms of number line? Already we have discussed this is minus infinity to infinity, as in between 0 will be there, here 2, right, on positive side. So x is less than 2, strict means open circle and this side. So this is nothing but x is less than 2. Now for this x is less than 2, how we will write this solution? Instead of number line, how we will write in terms of interval? Observe here, the solution, nothing but the shaded region. In between what? In between which two? In between minus infinity and 2, right or not? In between minus infinity, that means extreme values we need to take. That is minus infinity and 2. Here, when it comes to 2 is included or not included? That means 2 equal to 2 or not equal? Not equal. Not equal means we need to put open bracket. Not equal means we need to put open bracket. As minus infinity value, do you know the minus infinity value? We don't know. So as we don't know, we need to put open bracket, right? For always, whenever if you write minus infinity or plus infinity, we need to put open bracket. For these numbers like 2, 3, 4, for the numbers, if it is included, like if it is dark circle, then we need to draw close bracket. Otherwise, if it is not included, what we need to do? We need to draw open circle, open bracket. Next one, if x is less than or equal to 2, if x is less than or equal to 2, see on number line how we will write minus infinity to infinity. This is 0, and here it will be 2. Here equal to 2 now, one side equal to 2 means dark circle and this side. So this is the shaded region. Now the shaded region in between what? In between minus infinity and 2. Now for minus infinity always it should be open. For 2 it is included or not included? Yes, it is included. Why? Because equal to 2. Included means we need to put close bracket. Next one. If x is greater than minus 5. If x is greater than minus 5. So this is number line from minus infinity to infinity. So minus 5 here it will be there, minus 5, here it will be 0, here plus 5, right? Here equal to minus 5, not equal, not equal. That means here open circle. Now greater than or less than? Greater than minus 5. Greater than minus 5 means this side. So now this is the shaded region, right? Now this is the shaded region. Now how we will represent this number line in terms of interval? That is in between which two numbers the shaded region is there? Minus 5 to infinity, plus infinity. So minus 5 to infinity. So as I told that for infinity, maybe positive or negative, we need to put open bracket. For 5, it is equal or not equal? So as it is open circle, we need to put open bracket, right? Here another thing you need to remember, that is whenever we write in terms of interval, like see a comma b, like whenever we write in terms of interval, nothing but 2 in between two brackets, always you need to remember that a should be less than b. That means left side number should be always less than right side number. Here if you observe, minus infinity is less than 2 only, minus infinity less than 2 only. Here you should not write infinity comma, minus 5. This is wrong. Why? Because always left side number should be less when compared to right side number. So this is wrong. Minus infinity comma infinity. In this order only we need to write. For example, if it is having double inequalities, like x is greater than or equal to 2 and less than or equal to 5. X is greater than or equal to 2 and less than or equal to 5. How we will write in terms of number line and also in terms of solutions? Nothing but intervals. See, on number line we will write in terms of minus infinity to infinity, right? Now in between 0 will be there. Here 2 and 5 both are positive numbers, right? So this is 2 and here it will be 5, right? So here if you observe, those two are equal or not equal? Equal. That means one of the side is equal. Equal means we need to put dark circles. Now what is this one? You see, always read from x only. X is this side. X is greater than or equal to 2. That means this side. X is greater than or equal to 2. Right? This is one. And the other one is x is less than or equal to 5. X is less than or equal to 5. Right? So these are the two sides. Now should we consider, see, arrows are from here to here. That means should we consider from minus infinity to infinity? No, we should not consider like this. We need to consider the common region. What is that? That is 2 to 5. Now here 2 and 5 included or not included? Nothing but open circle or dark circle. As it is having equal signs, so it is included. Included means we need to put close brackets. Here close bracket 2 comma 5 in the sense x lies between, see, 2 comma 5 close bracket in the sense x lies between 2 to 5. That means in between 2 to 5 close brackets. That means also 2 and also 5. In between 2 comma 5 and also 2 and 5. This is about close brackets. This is example number 1. Next another example you see. That is, for example, if x is greater than or equal to 5, x is greater than or equal to 5 and less than 7. X is greater than or equal to 5 and less than 7. See, if we represent one number line, this is minus infinity to infinity. This is 5 and this is 7. One number line, all numbers will be there. These are infinity to infinity. Here what we need is 5 and 7. Now here for 5 equal sign is there or not? Is there. That means dark circle. For 7 is there any equal sign? No. So it is open circle. Now x is greater than or equal to 5. X is greater than or equal to 5. This side. Greater than. Now this one. X is less than 7. So this side. Now what is the common shaded region? Nothing but this one. This we write as 5 comma 7. See, as I said, in terms of interval, always left side number should be less than compared to right side. So 5 comma 7. For 5 should we put open or close? How we can write? By using either this one or by using this symbol. Greater than or equal, slack inequality. Slack inequality means close. Here this 7, for 7 which inequality is there? This is strict inequality. Strict inequality is in the sense either less than or greater than. So it is open circle. So this is 5 comma 7 semi-close bracket. See, here we will use brackets based on the symbols and based on the figure. It may be dark or close, open. So based on that figure we will use intervals. Those intervals are of close, open, semi-close. See, out of these 4, any one we will use based on the given problem. Right. Next we will discuss the union and intersection when it comes to linear inequalities. Next one, union and intersection. See, I think you know the meaning of union and intersection. See, union symbol is this one, like capital U. Intersection symbol is this one. So like this, opposite to the U. See, but these two symbols we won't use here. So by the concept of union and intersection, we will use, instead of union, we will consider as or. Instead of intersection, we will consider as and. Instead of union, we will consider as or. Intersection means and. Intersection is nothing but intersection, nothing but common part, nothing but and compulsory. Here union means all, nothing but we will consider as or. Now, how we will use union and intersection in terms of linear inequalities? See, I will give an example. If x is greater than or equal to 5, x is greater than or equal to 5 and x is less than 2, x is greater than or equal to 5 and x is less than 2. Now if we represent this on number line, see, minus infinity to infinity. See, here you should not write 5 and 2, 5 here 5 and here 5, 2 you should not write. Always in a minus infinity to infinity form only you need to write. First of all, here 2 will be there, here somewhere 5 will be there. Now if you observe, x is greater than or equal to 5. So dark circle. Here x is less than 2. Less than 2 means open circle. Now x is less than 2. less than 2 means this side. Less than 2 means this side. Right? Next, x is greater than or equal to 5. Greater than or equal to 5. That means this side. This side. Now, is there any intersection between these two? No. Now, in this case, what we will use is or, nothing but union. Union is nothing but this one plus this one. Right? This one plus this one. See here, that is how to write this one minus infinity to 2. Right? Why? Because these extreme values are minus infinity and 2. Here for infinity, open bracket. For here 2, open or close? Open. Why? Because open circle. Next, plus 5 to infinity, right? For this graph. 5 to infinity. Infinity always open. For 5, dark circle. Why? Because equal. So it is close. Now, but here we should not write plus sign. Now, instead of plus sign, what we will use is union. What we will use is union. That means minus infinity comma to union. Union is nothing but plus 5 comma infinity. So, like this, here we will use union in terms of linear inequalities. Here, next one is intersection case. Intersection case, for example, I will give an example. See, x is greater than or equal to 3 and less than or equal to 7. Greater than or equal to 3 and less than or equal to 7. If we represent on number line minus infinity to infinity, which is 3 here and 7 will be there here. For both, equal signs are there. So these two dark circles, right? So x is greater than or equal to 3. So this side, right? Greater than or equal to 3. That is that side. And this one, x is less than or equal to 7. So which is of this side, right? If you observe here, when it comes to this one, x is greater than or equal to 3. What is that? X is greater than or equal to 3. X is greater than or equal to 3. That side. That means 3 to infinity, right? X is greater than or equal to 3. 3 to infinity. Intersection. What is this one? X is less than or equal to 7. X is less than or equal to 7 means minus infinity to 7, right? Minus infinity to 7. Why? Because greater than or equal to 3 means this part, less than or equal to 7 means this part. Now we need to write intersection between this one and this one. Now what is that intersection between these two? What is the intersection between these two? If you observe the number line clearly, you will get this one, that is 3 to 7 close, right? This is the intersection part, right? Here these two are included in the sense equal signs are there, so close bracket in between 3 to 7, that is extreme values. Here, so here we will use intersection in inequalities, and like this we will use union in inequalities. Now we will learn some of the basic properties of linear inequalities. See, for example, if A is less than B, if A is less than B, for all this symbol, this opposite ulta A symbol is nothing but for all or for everything. For all, A comma B belongs to real numbers, right? Now, if A is less than B, right? If A is less than B, if I add C to on both sides, if I add C on both sides, nothing but A plus C less than B plus C. Nothing but here C, here C belongs to capital real numbers. Here C belongs to capital real numbers. Nothing but if I add any positive real number on both sides, right? If I add any positive numbers on both sides, inequality sign. What is there? Less than means here also less than. That means if I add positive number, real number on both sides, inequality doesn't change. For example, if 2 is less than 5, not if. Here 2 is less than 5. For this 2, I will add number 3 on both sides. That means 2 plus 3 less than 5 plus 3, right? Then 2 plus 3 is nothing but 5 less than 8. In between 5 and 8, unequal, correct or not, less than or not. That means if we add any real number on both sides, inequality doesn't change. That is property number 1. Next one. For A less than B, for all A comma B belongs to R, right? If I subtract a number on both sides, like A minus C less than B minus C, where C belongs to R, nothing but R plus, right? I will subtract a number, same number on both sides. Like for example, if I consider 5 less than 10, I will subtract a number on both sides. That is 5 minus 2 less than 10 minus 2. If I subtracting the 2 on both sides, 5 minus nothing but 3 less than 10 minus 2 is nothing but 8. Is inequality changes? 3 is less than 8. Correct or no? If we compare this one to this one, inequality doesn't change. 3 less than 8. That means if we add a positive, if we add a number on both sides, or if we subtract a number on both sides, inequality doesn't change. Right? For third one, if a is less than b, for all a comma b belongs to a c. Now here addition and subtraction we have done. Now we will check for multiplication. Multiplication with positive number and multiplication with negative number. Now in this third one, this is a. Nothing but multiply with positive real number. That is AC. That is if we multiply positive real number on both sides, that number is C. AC is less than BC only, where C belongs to R plus, where C belongs to R plus. If we multiply B bit, if we multiply with negative number, if we multiply with negative number, if we multiply with positive number, inequality doesn't change. I will give an example also. But if we multiply with negative number, what it will happen is inequality will changes. That means AC, if we multiply C, nothing but negative number, AC will become greater than BC, where C belongs to R minus. See examples for this. If we multiply, for example, if I consider 3 less than 5, if I multiply positive real number, nothing but if I multiply 2 on both sides, if I multiply with 2 on both sides, that is 3 to 6 less than 5 to 10. Inequality correct or not? That means for multiplication of positive number, inequality will be remain same. It doesn't change. But if you multiply negative number, like if you multiply negative number to this, what will happen? 3 into minus 2, minus 6. 5 into minus 2, nothing but minus 10. Can we write the same less than symbol? Is minus 6 less than minus 10? No, minus 6 is greater than minus 10. That means if we multiply with the negative number on both sides, inequality changes. That inequality, how it will changes means less than means it will become greater than means it will become less than or equal to means greater than or equal to, greater than or equal to means less than or equal to. Like that it will change. Now fourth one. Fourth is if A is less than B for all A comma B belongs to a, here plus nothing but addition, subtraction, multiplication over. Now we will consider division case, right? If I divide with positive number on both sides for this AB, right? Then AC will be less than BC only, where C belongs to R plus. Nothing but if I multiply, this is a division. This is A by C less than B by C only. When it comes to division of positive number, inequality will be same. But if we divide with negative number on both sides, then what it will happen? Inequality will changes. That means A by C will become B by C, where C belongs to R minus. See for this I will give example 6. For example, 4 is less than 10. 4 is less than 10. Now I will divide with positive number, that is 2. Right? Positive number 2. 4 by 2, 10 by 2. Nothing but 2 is less than 5. Inequality same or not? For 4 less than 10, if I divide with 2 less than 5, inequality change same. If I divide with, now for this, if I divide with negative number, nothing but negative 2, then 4 by minus 2 is minus 2, 10 by minus 2 is minus 5. Now in between minus 2 and minus 5, which number is more? So minus 2 is more. That means minus 2 greater than minus 5. Nothing but inequality changes. Right? When inequality changes, I will give those points in terms of words that you need to copy. Right? This one also, please copy this. What we have discussed the properties previously, those in terms of words. Note down these also. See, first one is if we add or subtract with positive or negative real numbers, inequality remains same. If we add or subtract on both sides of positive or negative real numbers, in addition and multiplication, in addition and subtraction, inequality remains same. Now, if we multiply and divide with positive real numbers, inequality remains same. In positive case, in negative case, multiplication case and division cases. In this, if we add positive number or negative number, if we subtract negative number or positive number or negative number, if we multiply negative number, and again if we divide with negative number, in all these cases, what we will get? Inequality remains same. Inequality remains same. Now when inequality changes, when it comes to third point, if we multiply or divide with negative real numbers, then inequality changes. Changes in the sense, it will changes to opposite sign. Opposite sign means less than means greater than, less than or equal to means greater than or equal to. It will changes to opposite sign. When in the cases of multiplying a negative number and again dividing negative number. For these two cases, what it will change? It will changes to opposite sign. Changes to opposite sign. Please students, note on this. Another basic properties are, that is point number 4, that is like if a comma b, belongs to a, see, if AB less than 0, here less than 0 in this sense negative, that means here A and B are negative, so real numbers. When AB is less than 0, nothing but when product of two real numbers will be less than 0, if A is less than 0 and B is greater than 0, right or not? A less than 0 and B greater than 0, or A is greater than 0 and B is less than 0, right or not? When product of two numbers will be negative, when product will be negative, when both are of opposite signs, less than 0, like minus and plus and minus is minus. That means when product of two numbers will be negative, when A less than 0 and B greater than 0, or A greater than 0 and B less than 0. Now, if when A comma B belongs to a comma AB greater than 0, nothing but when product of two numbers will be positive, when it will be positive, it means when both are positive or both are negative. That means A greater than 0 and B greater than 0. This case or A is less than 0 and B is less than 0. See, in these two cases, when both are positive, product will be positive, or both are negative, then also product will be negative. These are some of the basic properties. These 5 properties we have learned. And again, in tomorrow's session, we will learn properties of absolute values. Properties of absolute values, and again on triangle inequality. See, tomorrow we will discuss these two topics: properties of absolute values and triangle inequality. Now we will solve some of the problems based on what we have discussed from starting onwards. Those are let us start with an example. That is first one. Note down. That is solve 5 minus 3x less than 3x plus 1. Solve 5 minus 3x less than 3x plus 1. Here solve is nothing but finding x value only. Solve is nothing but finding x value. Now how to find this one? See, given 5 minus 3x less than 3x plus 1. Now bring these variables to one side and send the constants to another side. That is, this is a minus 3x. This plus 3x, if we send to left side, it will become minus 3x less than, this is plus 1, this plus 5 will become minus 5. Then it will become minus 6x less than minus 4. Now here actually, if it is like minus 6x equal to minus 4, if it is like terms of inequations, what we do? We will cancel negative signs on both sides. What we do? 6x equal to 4 and again x equal to 4 by 6, nothing but x equal to 2 by 3. So like that we will write. When in terms of unequal, we need in terms of equal signs we will cancel minus on both sides. But when it comes to inequalities, we should not cancel those two. What we need to do is we need to multiply minus on both sides. In order to remove this minus, we need to multiply minus on both sides. But according to property, if we multiply minus on both sides, what it will change? Inequality changes. That means minus into minus is 6x, less than will become greater than, minus 4 will become plus 4. To remove minus, what we need to do? Multiply negative on both sides. Then it will become 6x greater than 4. Then x is greater than 4 by 6, nothing but x is greater than 2 by 3. X is greater than 2 by 3. Now after solving this x value, we need to represent on number line and also in terms of interval. Now first one, in terms of number line. In terms of number line. See, this is minus infinity to infinity. This is greater than 2 by 3. If I consider this point as 2 by 3, equal sign is there? No. So it is open circuit greater than. So this side, right? So this is the solution in terms of number line. When in terms of intervals, interval or solution set also we can call. Solution set also we can call. That is 2 by 3 to infinity, right? 2 by 3 to infinity. For infinity open. For 2 by 3 is also open circle, so this is open. That means after solving 5 minus 3x less than 3x plus 1, what is the solution? 2 by 3 comma infinity open brackets. So this is how we need to solve problems on inequalities. Now comes to second example. Solve 4x plus 3 less than 6x plus 7. This is another example. See, if you understand the first one, second one you can do very easily. See, what is given? What is given? That is 4x plus 3 less than 6x plus 7. Right? So, as usual, bring the variables to one side, send the numericals to another side. That is 4x minus 6x less than 7 minus 3 which is equal to 4. Now, 4x minus 6x is minus 2x less than 4. To remove minus, what we need to do? To remove minus, we need to multiply minus on both sides, not only to one side, to both sides. That is minus 2x will become 2x. If we multiply minus on both sides, less than will become greater than, and again plus 4 will become minus 4. Then x will be greater than minus 4 by 2, that is x is greater than minus 2. Now this solution in terms of number line. In terms of number line, inequality, and also in terms of interval. And also in terms of interval or solution set. Simply solution set. That is on number line. Draw a number line at the straight line first. That is having minus infinity to infinity numbers. Greater than, this is 0, this is 2 and this is minus 2. Greater than minus 2. Is equal sign is there? No. So open. Greater than minus 2. So this side. So this is the shaded region, nothing but solution on number line. When it comes to solution set, in between which numbers the shaded region is there? Minus 2 to infinity. Minus 2 to infinity. For infinity always open bracket. For minus 2, open or close bracket. As it is open circle, we need to put open bracket. So like this we need to do. Here we can write, we can leave simply like this, or x belongs to minus 2 comma infinity. Like this also. Like this we need to write. It will be better. Next, two more examples from this linear inequalities. Third one, 5 minus 2x by 3 less than or equal to x by 6 minus 5. Fourth one, 3x minus 4 by 2 greater than or equal to x plus 1 by 4 minus 1. But when it comes to previous example like 3x plus 1 less than 6x plus 7, like that, you can send this 1 to this side, or you can send this 6x to this side and 7 to this side. Directly you can do, however you want. But when it comes to problems like this, whenever it is in the form of p by q forms, if a single number is there, you should not send these single numbers to right side directly. You should not send these single numbers to right side or left side directly. What we need to do is, so on which side it is there, right side or left side, right side. So first you need to do LCM here. Here also you need to do LCM. Then p by q we need to send to right side. Nothing but denominators we need to exchange on both sides. Did you understand? See, that is 5 minus 2x by 3 less than or equal to LCM. You take x minus 30 divided by 6. You need to take LCM, then you need to set this 6 to right side and 6 to left side, 3 to right side. Then it will become 30 minus 12x less than or equal to 3 into x, 3x minus 90. Now you bring this 3x to this side. So minus 12x minus 3x minus 15x less than minus 90. This is minus 30, which is minus 120. So then it is now if you multiply minus on both sides, if you multiply minus on both sides, 15x less than will become greater than 120. Then x is greater than 9. See now from this x greater than 9, right? Draw number line and also write a solution set. Right? Solution set. But in terms of intervals, x is greater than 9. See, if it is 9 minus infinity to infinity greater than 9, this is open circle and this side shaded region. This is on in terms of number line. In terms of solution set, in between which numbers the shaded region in between 9 to infinity. Infinity always open. Here 9 is open or closed. As it is open circle, it is also closed. Therefore, solution set is x belongs to 9 to infinity. Is the solution set for this question. Now when it comes to this question, this is also similar to this one. Observe here also one number is there even in terms of p by q forms. Then what we need to do is we need to take LCM. We should not set to left side or right side. So this is 3x minus 4 by 2 greater than or equal to x plus 1. If you take LCM, it will be 4. So it is minus 4. So that is 3x minus 4 by 2 greater than or equal to x plus 1 minus 4 is x minus 3 by 4. Now you do cross multiplication. 4 into 3, 12x minus 16 greater than or equal to 2x minus 6. Now bring the variables to one side and numericals to other side. 12x minus 2x, 10x greater than or equal to minus 6 plus 16, nothing but plus 10. Then x is greater than or equal to 1. X is greater than or equal to 1. Now this one also we need to write in terms of number line and solution set. Number line and solution set. On number line, so this is minus infinity to infinity, right? 1. See for this 1, equal sign is there, so it is direct circle. So greater than or equal to 1. So this side. So 1 to infinity. Now in terms of solution set, 1 comma infinity. Here 1 is open or closed. It will be closed by because dark circle and also equal sign. For infinity always open. Therefore solution set is x belongs to 1 comma infinity. Pause the video and note down. See guys, write the notes carefully and revise once again. If you have any doubts regarding the class, you can contact in that group, right? If you have any doubts also you can ask, and again if you have any doubts you can write it and you can do snapshot and you can send it in that group. If you have, see based on that I will clarify the doubt. Now see based on this class I will do assignment, nothing but some of the problems like this I will do. Those you solve it and submit in that group. Thank you for watching. Thank you.